10.4 hyperbolas. So the definition of a hyperbola is similar to the one of an ellipse. Remember that an ellipse is the sum of the distance to the foci. It's constant. So for an ellipse, D equals P times F1 plus P times F2. For a hyperbola, the difference of the distance to the foci is constant. So it would be D equals the absolute value of P times F1 minus P times F2. So we have two types of hyperbola, one that opens horizontally and one that opens vertically. So this one opens horizontally and this one opens vertically. So this would be your vertex at A and 0. You have another one at -8 and 0. Your co-vertices are going to be at 0 and B, and 0 and -B. Your foci are outside. So then they're going to be at C and 0, and -C and 0. These are your asymptotes. So the standard equation of hyperbola that opens horizontally is x minus h squared over a squared minus y minus k squared over b squared equals to 1. For the one that opens vertically, these are your vertices at 0 and a and 0 and -a. Your co-vertices are at B and 0 and -B and 0. Your foci are at 0 and C and 0 and -C. And the standard equation is y minus k squared over a squared minus x minus h squared over b squared equals 1. So to write the equation of a hyperbola, let's take this graph. The first thing you need to do is you need to identify the form of the equation. So we're doing this one so we know that this is the form of the equation because it opens horizontally. For part 2, you need to identify the center and the vertices. Well, here, the center is at 0, 0. Remember that your center is your h and your k. So then your vertices are at -8 and 0 and a and 0. In this case, the value of a is 2. So it would be -2 and 0 and 2 and 0. Now we need to find the co-vertices. The co-vertices are at 0 and B and 0 and -B. The value here is 3 for B, so it would be at 0 and 3 and 0 and -3. So now we have all the information we need. We can write the equation. Once again, A is 2, B is 3. So our center was 0 and 0. So then it's going to be x minus 0 squared over a squared, which is 4, minus y minus k, which is 0, squared, over b squared, which is 9, equals to 1. So x squared over 4 minus y squared over 9 equals 1. And that's your equation. Now for graphing a hyperbola. If I give you the following equation, y minus 5 squared over 4 minus x minus 3 squared over 25 equals to 1. First thing we need to do is we need to identify the form of the equation. As you can see, it's y minus k over a squared minus x minus h over b squared. So it's going to be a vertical. So the standard equation is y minus k squared over a squared minus x minus h squared over b squared equals to 1. So we need to identify the center and the vertices. The center is at h and k. Our h is 3 and our k is 5. So our center is at 3 and 5. Since the movement of the vertices happens on the y-axis, then we're changing our y's. So your vertices are at h and k plus a and h k minus a. H is 3, so it's going to be 5 plus your a. Our a squared is 4, so a equals 2. So plus 2 and 3, 5 minus 2. So it's 3 and 7 and 3 and 3. For the co-vertices, our b squared is 25, so b equals to 5. And the movement is happening on your axis. So it's centered at 3 and 5, so now it's going to be 3 plus or minus 5, and your y stays the same. So your points are at -2 and 5 and 8 and 5. Then we need to find the equation of the asymptotes. For a vertical hyperbola, you go 8 units down and be down or up, and b units to the left or to the right. So we start with the point slope formula. Y minus k equals plus or minus a over b times x minus h. We're using the center because we're starting at the center. So our k was 5, our a was 2, our b was 5, our h was 3. So then we can say that the equation of the asymptote is at y equals plus or minus 2/5 times x minus 3 plus 5. Now we can draw. First, we're going to draw a box, and we're going to use the vertices and co-vertices. So we're going to start at the center, 3 and 5. Okay, so then we're moving 2 units up, and we're moving 5 units to the right and to the left. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 2 units down. So you can draw your box. So the asymptotes go through the corners of the box. And remember that we said that this hyperbola opens vertically. So since this is your vertex, it opens up and it opens down. And the asymptotes help you to graph it. So the last part is finding the foci. Remember that for the ellipse, to find the foci, it was c squared equals a squared minus b squared. Well, now for the hyperbola, that's going to be c squared equals a squared plus b squared. So a squared was 4, and b squared was 25. So c equals the square root of 29. So the foci will be located outside your vertex. So the movement is happening on your axis. So if it was centered at 3 and 5, the foci is going to be at, sorry, I said the foci was at in your x's, it's on your y's. So it's going to be 3, 5 plus the square root of 29, and 3 and 5 minus the square root of 29. So that's your foci.